Let's take a look at the final section, which is about probability trees. You've seen them before. It says the only difference is conditional probability. That's pretty much the difference between year one probability in the stats to year two is the inclusion of this conditional probability. Okay. So you have 2 bags, the first with 5 red balls, 5 blue balls, the second with 3 red, 6 blue. You first pick a ball from the first bag and then you place it in the second. So you take one from the first bag and you place it in the second. So what's going on here then? Well, they're connected, aren't they? Yeah, if you think about it for a second, what happens the first time around is affecting what happens the second time around. Okay, so you just need to think about what's happening carefully. You then pick one for the second one. Okay, right. So to start with, then the probability of a red one and a blue one is a half and a half, isn't it? 5 out of 10, 5 out of 10. But let's just walk through this. So if you pick a red one, what actually happens? You first pick one from the first one and then you place it in the second. So the second one has this 3 and 6 situation, but it doesn't stay as 3, 6, does it? Because if you add another red one, that's changing to a 4. So if you pick a red one, it increases the probability that you pick a red one again, 4 out of 10. And if you pick a red one the first time around, well, it's still the same. The first time around, you pick a red one, you put it in. So there's 4 red, 6 blue. Or if you prefer, you can use the fact that these should add up to 1 to answer the question. Okay. So if you pick a blue one, and then you put it into the second one, well, the second one will still only have 3 red, but then this will increase to 7. So you're talking about 3 out of 10, and then you're talking about 7 out of 10. So hopefully that makes sense. What I'm trying to do is I'm just trying to picture the situation, get into the context of the question. If there's one thing I think students don't do enough, is you don't often read the question slowly enough and just try and think about what's actually happening. Okay. Now we're in the position to do something, hopefully. So hence find the probability that you pick a red ball on your second pick. So we're talking about a red one. So it's 4/10 and 3/10. So we're using these strands here. So what are we actually doing? Well, we're going to do, the probability is going to be red and red. So red and red is going this way, which is going to be a half times 4/10. So a half times 4/10 is 4 over 20, which is 1/5. Okay. The other way that you could achieve this is you could do blue and then you could do red. So a half times 3/10, 3 over 20. Okay. So remember, with a tree diagram, you multiply along the branches to find these probabilities at the end. So for example, that's a 5th. That's 3 over 20. I haven't worked these ones out. And then you add the ones that describe the situation you're talking about. So 7 out of 20. What about this one then? So given that means we're going down the conditional road. Now, we probably could use the formula and stuff, but let's just see if we can use the diagram. So given that your second pick was red, in other words, we're here or we're here, aren't we? This is the only thing that could have happened. So given that your second pick was red, that the first pick was also red. So if you are at one of these, what's the probability that red was the first one that you picked here? Well, your whole sort of world, if you like, has been shrunk down to this 5th and this 3 over 20. So which one describes where the first pick is also red? Well, it's this path, isn't it? It's this path out of the 2. And that path was described by 1/5. So the chances that you're on the top path is 1/5 out of the 2 situations that you've described, which is 7 over 20. So this is the calculation that we could do. So a 5th out of 7 over 20. So the given that sort of shrinks the question down. As soon as that happened, the blues didn't really exist. Okay, they didn't really exist. We were either on this top path here or we were on this bottom path here. So that's what it was out of. So that's why I used this for the denominator. And then I was just trying to pick the situation that was described, which was the first one is red. Okay, and the probability for that branch, that path, we already worked out as 1/5. So 1/5 out of 7/20. So you don't need a formula or anything to work that one out. So we've got a further example here, and then a test your understanding. Let's have a look. C, B, and F. What's this all about? Car, bike, and foot, by the look of it. So the probability that he travels are these things. Okay. And then the next thing is about late and not late, not late, late, not late, late, not late. Okay. So what are we doing? So given that Bill is late, so where are we if we know that he's late? Well, we're not on any of these because we were told that he was late. So we're not interested in any of those branches at all. So you can get rid of all of those numbers there. So we're either on this branch, a fifth multiplied by half, so that's a tenth. Or this one here, a sixth multiplied by 2/5, so that's 2/30 or a 15th. Or we're on this one here, which is 1/30. So this is sort of this is our total that we're going to have a look at. I suppose we could make that 3/30, 2/30, and then we've got the same base. So the denominator that I'm going to be talking about, given that he is late, it's going to be out of the late situations, which is 6/30. Okay, now what's the other part then? Find the probability that he did not travel on foot. So that he did not travel on foot, whereas foot is this one here. So I'm not going to be too crafty with this. What I'm going to do is I'm going to say not on foot is this one or this one, isn't it? Because car or bike satisfies those conditions that it's not on foot. So I'm going to do 3/30 plus 2/30 out of the possibilities for that one there. Okay. And yeah, what was this? This was our, let's have a think. That was our 1/15. So that's this one here. This one was our 1/10. So it's that one there. And these are the things all added up together, which is that one there. So you should end up with a final answer of 5/6. Pause the video then and have a quick go at this one here. Okay, so your tree diagram should look something like this. Find the probability that the second ball is red. So there's the two red scenarios. Given that, start with the given part there. Given that the second one is red, so out of 1/4, which you answered in part B, that they are both red. So they are both red is 3/12 multiplied by 2/11. Okay, so notice sort of a connection between these two parts. You've used this part to help you answer this. Seems to be a common pattern. And that takes you towards the end of the probability part for year 2, chapter 2.